Hey, Sunshines. So we're doing the angle addition postulate. This is a slightly harder example where instead of being given an angle measure for one of the interior angles, I'm being given a relationship between the two pieces. So I know that angle CAB, that's the big angle, is 120 degrees. And I know that angle TAB is half the size of angle CAT. So I want to find angle CAT, so that's going to be X. And then TAB is half the size of X. So it's 1/2 X, or if you prefer to work in decimal, you could do it as 0.5 X. I recommend sticking to fractions because for 0.5, it works, there's no rounding, but if you have 1/3, then it would be then you'd have to round off. It would be 0.33333 infinite, and you don't want to end up having rounding errors and mess up your answer because you rounded off. If you call it 0.3, then you're going to throw your final answer off by a little bit. But so we're still going to use the angle addition postulate to set up our equation. We know that the two small angles add up to equal the larger angle. So if I know that angle TAB is 1/2 X, and I know that angle CAT is X, and I know that angle CAB is 120. So I want to solve this equation. Now I've got a fraction coefficient here that I don't really want to deal with. So I would multiply everything by 2 to cancel out that denominator. So 2 times 1/2 gives me 1. And then 120 times 2 is 240. So x plus 2x is 3x. You also could have done this with improper fractions and just said that this was 2/2. So it's 3/2, and then 3/2 x equals 120. But I prefer just getting rid of my fractions wherever I can. So out of x equals 80 degrees.